All right, so we're going to continue on with the industrial network. All right, we've been hitting up networks and Ethernet and all sorts of wonderful things so far. Right? And you're probably getting tired of hearing the word network. And luckily, you guys are in an industrial networking class, so I'm going to keep coming. All right. But anyway, so the industrial network. Go to the next slide. Here we go. So, what is a network? All right, we have devices, we have the wiring, and we have the protocol. So whenever you're thinking about any sort of network, all right, you're going to need all these types of things. All right, you're going to have devices. If you don't have devices, there's no point in having a network. All right, so it's and why do we have this network? Well, probably for sharing something. Your internet, information, printers, data, something. All right, we need to have some sort of wiring. Now, wiring, I'm gonna put that one in air quotes, and mainly because of air, right? We could have a wireless network. Right? Your phones are all using wireless networks, whether it's for Wi-Fi in the buildings, or whether it's for 4 or 5G out in the real world where you're driving around, or whether you're making a phone call. You are still on a network, and depending on what you're doing, it's a different network. Right? And this drives me nuts with T-Mobile. Right? I've got my phone, and I'm on the network. And it's like, you got great service. I'm like, cool. And I'm like, let me make a phone call. And it's like, you don't have any service. I'm like, what? Well, it's like, you've got great service because I've got 4G, but when I go to make a phone call, it takes me back to the older technology. So it's like, oh, now we're looking for the 2G or 3G networks. And then it's like, oh, wait, they're not around. I'm like, no. All right. So, kind of annoying in that aspect. It could be my SIM card, to be fair. I did take my old SIM card and I cut it down to fit in my phone, so I really do need a SIM card. So that could be the problem. But anyway, air is a network. It is a transmission medium. Maybe I should change wiring to transmission medium. I'll watch that lovely video. All right. And then you need protocols. And if we don't have protocols, we're not speaking a language. That's what a protocol really is. It's telling us how everything is set up and how it's going to communicate. Like I said, I don't have an example for this. It's like, okay, go to McDonald's and order something. You're blind and deaf and you walk into McDonald's, you don't know where to go. All right? Use our eyes to help navigate us to the front and all those other fun things. So we need to have a system in place to help us place our orders or communicate. That's really what I'm saying here. All right. Now, the internet, we have talked about this a little bit. This evolved from ARPANET, which is the Advanced Research Project Agency. I told you I'd come back to this. I told you it was the precursor to DARPA. Forgot what it was, but it's ARPA. All right. And this was the first operational packet switching network. Right, so we're actually sending packets of information, and we were determining whether we send on route A or route B, not just like a long serial connection, basically. All right. This was mainly applied for the whole tactical radio and satellite nets. Oh, sorry. The network was so successful that they actually used that same packet switching technology on tactical radio and satellite networks. Let me fix that one. All right. And the need for interworking between these two things led for the development methods of the TCP/IP. So that's why we're standardizing. It's like, oh, we need all these things to work together. We have to standardize. Having things non-standardized is just no fun, is really what it comes down to. So, now, a quick little precursor. So here's kind of like I'm going to go this a little older school here, right? But this was how we kind of had this thing set up. So we have the source, which would most likely be your computer, and that's generating the data that's to be transmitted. Then we have the transmitter itself, which in this case is a modem. So that's converting the data into transmittable signals. Then we go over the transmission system, which would be in this case again, the public telephone network. We have a receiver, again, another modem, that converts the signal back into data. And then we have the destination, which is our server at the very end. All right. Now I said this is a little antiquated, or if I didn't, I know I just did. Because this is talking about an old telephone network. All right, how many of you guys are still using telephone network to get on the internet? Any of you guys ever use a telephone network to get on the internet? Really annoying, lovely noises as you dialed out. And if you only had one phone line into your house, you couldn't make or receive phone calls while you were on the internet. It was lovely days. All right, but anyway, that's what this one is showing you. Now, we haven't gone too far from this whole modem point here, all right? Especially if you are using broadband internet, right? If you have like Antietam cable, you are still using a modem because the modem is taking digital signals and converting them to analog. Right? It's a slightly different than the whole public telephone network, but it's basically the exact same. Now, if you are not doing that, if you're doing something more like fiber optics nowadays, which there's a lot of options for fiber optics, you're just doing digital to digital, so we don't have a modem in that instance. We have what it is, transceiver or something that's converting your one signal type to another. You're going from copper electrical signals to light signals. So there is some sort of transverter going on there, but it's not a modem. Something else. All right. And here it's just showing you the whole digital to analog converter. So you've got your digital source, sending digital information to the transmitter going all analog on it through the transmission system, still analog, back to the receiver, converts it back to digital, and then we have our destination. So nothing too overall, in my opinion, crazy going on there. All right. Yeah. So here we have internet architecture. Now, this is nowhere near accurate. All right. This is just a little representation. But say you are at your house, you would be one of these little computers. And by you, I mean your whole network would be one of those little computers. And you have all of your different regional IPs here. So you would have Antietam. It's going to go with Antietam. Yeah, that would be this one. And then you would have Point. That would be this one. And Comcast is coming through. That would be this one. All these different ISPs. They're all local, so they're all real close to each other. As you notice, they've all got little direct lines going from each other to each other. All right. So we're all connected, right? You send information to your friend next door, the information goes there. It may go from your house to your ISP, to a different ISP, to a different ISP to finally get to your neighbor's house, depending on whose internet. Seems kind of crazy, and you're like, I need to send it 30 feet that way. But we're going to go 1,200 miles on cable by the time we get there. Same thing happens with your cell phone, by the way. If you make a phone call, right? And it's like, okay, I'm calling my wife right here next to me because she doesn't know where her phone is. It goes from me to a cell phone tower, through miles and miles of cables, back to that same cell phone tower to my wife's phone. It's not like it's like my phone to the cell phone tower. Oh, she's connected here too. Right back out. So sometimes it's going through miles and miles and miles of cable. So just something that you do need to be kind of aware of. A little bit annoying there. All right. You should all know this. ISP is your internet service provider. Should have said that one already. All right. So we do that. We have backbone ISPs. All right, those are all these kind of like dark blue lines and stuff. So those are one big section. Notice that we've got another backbone ISP over here. All right, so we've got some NAP network. Do I have that? No, I don't have that one. I don't remember what that NAP stands for, but we got some integration going on here between these two for protection or long distance or whatever the case. So we've got some stuff going on there. But anyway, so we got these big backbone ISPs that are sending all information. Again, your ISP is paying them when they're sending information over their lines, type of thing. I am glad I am not the one trying to keep track of who owes me money when it comes to these things. I mean, it is all automated, I'm sure, but like the rules that someone had to write, oh, you transmitted 30 megabytes through my this line, and you took 10 minutes on that line. I'm like, no, I don't want that job. I don't want to come up with all that wonderfulness. So, but anyway, so again, it's like, oh, when you send your information from you coming all the way over here to this server, maybe that's Amazon, you're like, okay, hey, I made it there finally. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps basically to get from you to them. And then they send information back to you, and they're like, oh, we're going to go this way. Yeah, that could be the route back to you, because whatever reason, all those other shorter paths from here to here, like that one, that could be down, or it could be oversaturated, or whatever the point is. So it's like, oh, yeah, we're going to send you this way. And you get to the next stop, it's like, oh, you need to go that way. And they just keep popping you down the line to get to where it is that you finally need to. I will demonstrate this for you guys in a little bit. Let's just do it now. All right. So there is a lovely tool called Traceroute. Ooh, there we go. So tracer, there we go. And I'm gonna go to Google. Boom. All right, and this is showing us all of the different hops that it takes to go from point A to point B. So the first hop is to 172.20.64. Then it goes to 172.31.252. And then it goes to our external IP address. And then it goes here. And it's just going to keep hopping until it gets to google.com. All right. So how many hops do you think it's going to be to get to Google? Any takers? 12 hops. 15, 17, 12, and 17. All right, so there you can see we did finally make it there after 21, but with a whole bunch of timeouts, so count those or not, your choice. All right, and as we were talking about, the traceroute command is used to determine this path between two connections, and this is often a connection to another device. We'll have to go through multiple routers, and the traceroute command will return the name or IP address of all the routers between the two devices. All right. And then someone asked about the why are there 3, and this says each line shows the name of the system as determined by the name of DNS, IP address, and 3 round trip times in milliseconds. All right, so it's just, again, how long it takes to get from here to there and back in milliseconds. So anyway, so that's just kind of interesting. Now I'm just kind of curious. What if I do that same thing, except for I do google.de? I think D is Germany, if I remember correctly. And I'm just kind of curious. I mean, a bunch of these should be the same, and then all of a sudden it should be like, oh, now I'm going over this intercontinental fiber optic cable. It's under the water. All right, so it'd be kind of interesting to see where this one goes. So anyway, yeah, the how long it takes to actually get there. No, I don't think these timeouts are. All this, as you can see, is a little bit spaced. This is not real time. This is like, oh, okay, we've got the next name. Let's ping that next one and see what happens. Like, okay, we got the next one. Let's try it again, type of thing. So it's not, obviously it doesn't actually take that long to get there. Now, just because I'm curious. Yeah, so we have different IP address here. If we look, the google.de is 172.253.6294, and this one was 172.253.115.114. I am curious. The address, look up. Let's see, 172.253.94. Google.de is still in California. In case you guys were curious. All right, 253, what was it? 115.104. I would have thought it would have been going to Germany. We're not actually in Germany. We're basically going to the exact same spot in California. The other thing that these timeouts may be is that the routers may be set up to not reply to pings. So it may be going, hey, and it's just like, I'm just going to ignore you until you go away type of thing. And that is pseudo a security thing. It's like, yeah, you can't ping me. I'm not here. And, it's I'm not going to call it good security, but it's a little layer of security having those. Let's just ignore those responses. So all of those could still be steps in this trace route. It's just not responding to us. No, I think these are still being.
Just kind of go through it.
Yeah.
Okay.
I'm thinking that's what this is. At least. I could be horribly mistaken. Don't get me wrong. All right. Now it is kind of interesting. I could do this. I have. Hold on a second. All right, so we're gonna do this trace route from the same IP address to the same IP address. So now we have a VPN on, so it thinks we're in Germany. So we're gonna see how that goes. So just a reminder, I have a VPN on. So our latencies are going to be higher because now all of my data has to be sent from here to that VPN server in Germany, and then from there to the next location. All right, so we have a lot more distance to cover for timing. So that's why we have these much higher MIL timings on here. All right.
I thought
Nope. Yeah. So what's happening is we have basically an encrypted tunnel for VPN, that goes from here to wherever that server is. And all of my data goes from me to that server. And then from that server, it then goes out to the World Wide Web.
Yeah, that makes sense. You see it like show.
Yep.
Actually sending the data over to.
Exactly. So yeah. So as far as any of these, if you're trying to access something through a VPN, it thinks you are physically located at that server's location. All right. So that is how this is working. So we're gonna let this run in the background, and we'll come back to it in a few minutes so we can see how it ever actually completed. Yep, I like that one. That one's name. All right. So anyway, so that's kind of Tracer. It's just kind of interesting to see the path. And you could do this on your local network. You could be like, okay, I want to see where this projector is or whatever, and I could take that and I could see what the router path is from me to it if I knew the IP address and everything else, and if I was allowed to see said network projector. Right? That's the other game you have to play, because again, if we have VLANs, it's like, no, you can't access that. We'll hit a brick wall somewhere. Kind of just an interesting thing. So, but anyway, back to this. Now we are finally going to actually talk about the OSI model. I'm still zoomed in, thank you. This button, and back to that one. Anyway, OSI model. I have talked about it. I think I've showed you all the names before. I've showed you the little graph. And I am by no means an expert on the OSI model. All right. So what we're going to do is we're going to watch a lovely video on the OSI model. Right. So if you go to our D2L, and it's this first one, this video that we're watching. So it's what is an OSI model, and it is by RealPairs. All right. So now you watch the video. Hopefully you understand OSI a little better. But it's really quite like all-inclusive. I mean, it covers everything from the physical hardware that you are using, including like just the power supply, all the way up to the actual like application software that you're using on the computer. So it's the whole gambit and everything in between is what's going on here. So this is why that OSI model is really important. It's also kind of important for troubleshooting to figure out where you're having a problem. Is it with the software, or is it with the hardware, or is it somewhere in between? All right. So that OSI model, it is a royal pain in the butt. I'm not going to argue that statement with you at all. But it is definitely something that you guys dealing with networks are going to hear about. And it doesn't really matter what networking system you're dealing with. You're going to probably hear about the OSI model. Or, oh, is that level 3 or level 6 or what's going on? Again, I'm not expecting you guys to become experts. I hope you should be able to identify which ones of these are OSI layers and which ones aren't. Maybe even the order. Probably you should know the order of like 1 to 7 what they are. Right? So just kind of something to keep in mind. All right. Now, our ping did finally complete, so let me go ahead and pull that back up. That 5. There we go. All right, so it was actually only 27 stops, which I find kind of interesting. And I did go through. Now we need to go back to the screen. I did go through and just kind of look up some of those IP addresses where they are. So No Man's Land, that is in Europe. All right, as you can see here. And then I looked up another one, and that was in California, which is kind of interesting that it was No Man's Land, then California, and then all of a sudden we're going to Japan at some point. So like, I'm not quite sure the path that we took to get to this endpoint. All right. The what?
Yeah.
Oh, the first one? Let's see if I type that one in. Copy it. That is in Germany. I think that was my VPN, is basically what's going on. But let me turn my VPN off before I forget. But anyway, it is kind of interesting to me just to kind of look at that. And the other thing I want to show you guys is this map. These are all the underwater cables that's connecting everything. All right, so you would think like it'd be like, okay, we need to get to this side of the United States. And this is just showing you underwater. This isn't showing you like land-based stuff. But it's like, okay, we're going from Germany. And they came out here to the United Kingdom or Ireland, was it? I think it was No Man's Land. And then somehow we made it all the way over here to Japan. I didn't check every point in between, but it was like here, and then it went to California somehow. and then it, all of a sudden it was over here, and then we kind of came back, and I'm like, this just doesn't make a lot of sense to me. I was hoping to be like, oh, look, we probably used one of these 6 cable, and obviously that didn't happen. So, but it's just kind of interesting that you can actually see all these different underwater cables and whatnot, and where they're connected, and how many of them are connected here into this area. This is yeah. So just kind of an interesting thing to be able to see all those different networks and whatnot. All right, any questions between those about the whole trace route? Just kind of seeing the path of stuff line, talking about the OSI model. You all just don't know what questions to ask about the OSI model. I don't understand. I don't have a great answer for you either. What shouldn't ask. But anyway, yeah, okay, we'll just continue on. Here we go. All right, so some different network types. All right. Now, which of these do you guys recognize? LAN? LAN, you said? What? VPN? Had LAN on there twice. You can. No, it just doesn't exist. All right, so good. LAN, you all should know that one. Local area network. That's what you have rocking at home. All right. This is traditionally a smaller scope, either a building or a small campus. All right. This is usually owned by the same organization as the attached devices. Like in your house, your LAN, everything that you have plugged into the network there is probably your property, right? Or at least someone you know. Your data rates are going to be probably much higher. You're talking the gigabit network speeds, maybe even 10 gig network speeds at home. Small businesses probably has some good 10 gig. So yeah. All right, WAN, again, you all hopefully would have heard of, especially if you looked at your router really close. It probably says WAN next to the little yellow port. All right, so this is your wide area network. This spans a large geographic area. All right, this is going to be across public rights of ways. So it's like, oh, okay, we're going from here across the city or something like that. You're leaving your own house. This is not going to be owned by one company. Right? If we think about what we all qualify as the WAN, that's the internet, right? You plug your WAN port into your modem, which goes out to the internet. So the internet is kind of the WAN. All right. Not exactly the same thing, but kind of close. Yeah. And you're going to rely on common carrier circuits, which are an entity that provides wired or wireless communication services to the general public for a fee. Right. Underneath WAN, we got MAN, which is a metropolitan area network. This is a middle ground between LAN and WAN. Not surprising there. All right, this could be public or private. Probably has decent high speed and covers a large area. I would call HCC to be a MAN, personally. All right, I would say HCC, every building would be its own LAN. Just going to go with MAN, LANs, and WANs. All right, HCC, every building would be a LAN. The campus as a whole would be a MAN. And then once we leave campus, that's something. I know, all the freaking hands. Right? All right. Oh, this man's probably supposed to be PAN, P-A-N. All right. So PAN is a personal area network. So this is even smaller than the LAN. So up here, we've got the biggest. Down here at the PAN, we have the smallest. All right. And that PAN, personal, extremely small. What extremely small networks do you guys create? What about your phone? Okay, hotspot I would qualify as a PAN. You have your phone hotspotting, and okay, you have your laptop that goes to your phone, and now that could be to use the internet off your phone, but it's still a little personal area network. All right. Many of you are actually also using like Bluetooth headphones. That's a PAN. Your phone is sending information from your phone to your headphones. Bluetooth is only like about 30 feet traditionally. Right? I think technically it can go like 300 feet, but normally you see like these advertisements. It's like 30 feet range, that type of thing. So it's just kind of an interesting one. So PAN is it? So Bluetooth is probably a great example of a little PAN you might have. If you do just like plug 2 computers directly together in Ethernet, that would be a PAN too, right? Because again, you're just a little network right there. Okay. Now we've talked about VPNs, virtual private networks. Obviously, I just used that. All right. And again, a private network that basically again makes my computer look like it is on the network of somewhere else. So I connect it from here to a network in Germany, And as far as everything was concerned, I am not physically attached to the network at all, right? I'm going from here through a whole bunch of public, private internet connections to there. But as far as everything was concerned, I was physically sitting at that network plugged in with Ethernet cable. Right? And this is great for more reasons than just obscurity, right? It's obscuring where you actually are, right? Great example of this is I have a VPN set up to my house. So I can log in and I can connect to my printer at home. I can connect to my file server at home. I can do my home automation. I can, modify my router settings. I can do like anything I can do at home. If I connect my VPN, it's literally like I'm sitting at home on my computer, but I can be anywhere that is internet. Right. So that's the whole point of a VPN. It's to allow you to access resources that are only in a specific location. Right. And it's traditionally a very secure system. Right. We're talking maybe 256-bit encryption or higher, maybe less. It all depends on how the system is set up at those times. All right. So VPNs, they are great for allowing you to access things securely from a remote location. All right. And the reason it's secure is because everything between you and the VPN connection point is an encrypted link. So it doesn't matter what you do, everything that goes from you to that server is encrypted. Now, from that server on, it might not be encrypted. So if like you just go to http your bankofamerica.com, right? And if it's not secure, people between you and that server, they can't read your data. But from that server on, they could read your data if it wasn't a secure link. So that is some important thing. Now, at the same point, this having access to all those local resources is great. It's also a security issue because if someone gets access to your username and password, they can now log into such and such network and have free reign over anything on that network that you would have access to. So there is good and bad going on with the VPN. You need to definitely take that into consideration. Username and passwords are okay. All right, security certificates, SSLs are even better. They are, 200-300 characters long. So it's not something that you're just going to be like, yeah, I'll just memorize this and type it in every time like a giant password. So that means that file is now something they have to have access to as well as your credentials. A little bit of give and take going on there with a VPN. And then that leads us to the last one, which is the VLAN, which I have talked about briefly in this class before. All right, virtual local area network. All right, so this allows you to be, again, it kind of creates a virtual local area network. So it stands for, right? So if our local area network is this building, right? Just think about a building as a virtual. Well, maybe you want to subdivide all your buildings into like different sets. Yeah, the lights in here randomly turn on and off. Just deal with it. All right. So again, like we have wireless networks here. Now there are mobile carts. So I have that cart of laptops in my closet back there. All the laptops on that cart connect to a mobile cart Wi-Fi. Right? Which means that if I turn one of those on and I'm in this building, or I'm in the STEM, or I'm in CP, doesn't matter what building I'm on campus on that Wi-Fi, they're all basically acting like they're in the same building. All right, maybe even the same freaking. That crazy. Right? But it allows us to do that. It allows them to share resources that they're supposed to and not supposed to. But it also, again, it's a security issue because as students logging onto those mobile carts, it's like, hey, you might need access to our servers on campus because we have licensed servers. They do. I have license for my PLCs. They have to go to a licensed server. If you get your personal laptop on, you connect to HTC's Wi-Fi, you're like, I'm going to install the software, I'll use the site license server. You don't have access to it. Right? So when you log on to HTC's Wi-Fi, you're on a different VLAN probably that keeps you from accessing it. So it's physically like blocking you off. You're like, hey, I need access to this port. And it's just like, nope, can't have it. You're not allowed to go there, type of thing. All right, so it's kind of a weird system, but it is great for security and grouping like things that aren't actually in like areas. That would be your VLAN. All right. Yeah. All right. Any questions on those? No? Awesome. All right, let's move it on. All right, so we've already hit up Ethernet. We've talked about all of these things before, except for one. Anyone know what this is? PoE? No? Nope. All right. PoE is power over Ethernet. Oftentimes we have devices like the wireless access point up there. Right? It needs Ethernet, it needs power. Well, okay, so now we got a power brick we have to plug in. So now we have to get an electrician to come in to install an outlet up there so we can plug our wireless access. Right? And that has gotten to a point of being too much work, really, when it comes down to. Right? So a system was developed called PoE, which is Power over Ethernet. So not only are we sending our data signals over the Ethernet cable, we're also now sending power over that Ethernet. So that access point doesn't need anything other than a single Ethernet cable to get plugged into. Now there are, I'm going to call it two different systems for PoE. There is the correct PoE system, and then there is the hacked PoE system. Right? And the hacked one is basically, so in a nutshell, when you're using 100 megabit internet, you're only using 4 of those Ethernet cables. All right, so this would be your Ethernet, and then this power. That means that we have 4 cables that we could send power over, and they're all inside the same connector. All right, so that's the hacked one. You can just go, all right, let's just break these out. We've got this magic box that we're running Ethernet cable into. And then we'll have power come in over here, and we're just going to take some of these cables that are on the power, and we're going to hook them into the Ethernet port. And then we're just going to not connect the actual Ethernet wires to those two. So that way everything's completely separate. Right? I said it's a little hacky, but it is something that does get done. Right? And as long as you only have 100 megabit internet, perfectly fine. All right? As long as you know that this cable that I have here is set up this way. And traditionally, you'll have a box on both sides. You know, you've got your hacked PoE adapter. All right, on both sides here. So you have Ethernet come in one, you've got power come in here, and they both get there. And then again, you have Ethernet come out, and then you would have power come out. All right. Now, again, the reason I say you need to be careful with this is, plug this into something that's not expecting 24 volts or 90 volts or whatever on those wires, that's when you have a bad day. Right? So while that system does work, and there are a lot of those types of things out there, that really is a crappy system. Right? So what you really want is, really understand. So we still have other PoE systems, all right, but they follow an official standard. So they're not just breaking out 4 wires running power over them. They're actually supplying power on the data lines. And if you're like me, you're like, how the hell is that possible, right? I'm going to use wires, I'm going to send power over. How can I still send data over? And the key or the secret is digital, when we're signaling, we're pulling things high and low. All right? All right. Now, so we have this digital signal, we're going high, low, come over, high, low, whatever the pulses that we're sending. It doesn't matter where this magical 0 point is. So it could be, okay, that's at 50, 0 volts, or it could be all the way up here, and we can send that same signal all the way up here at 50 volts. So we just have a 50 volt or 90 volt or whatever base carrier voltage. That's our 0 point. Anything above that is positive, anything equal to that is 0, or whatever the case is here. So we're actually adding signaling on top of that. So kind of crazy how that works. But we are actually able to do that. So this is an official standard, and you need to have devices that are officially supported by this. And you need both sides. So you can't just take any old Ethernet switch like the one we have on that rack that is not here anymore. You can't just take any old Ethernet switch, plug a PoE power device into it, and go, yeah, it's going to get power. No, it's not going to get power. Right? You need a PoE rated switch. All right? And there are also different versions of PoE. All right? I know of PoE and PoE Plus. I know there's a PoE Plus. Right? And PoE Plus, I think, is higher voltage, maybe more current, or just higher wattage or something like that. All right, so you need your switch to be able to handle it, and it needs to be able to, switch power to whatever. And then your device has to be able to handle it. Make sure they're both using the same system communication, and the voltages and everything are acceptable. So you need to double check on those types of things. But it is a super convenient way for running overall low power applications, like an access or a security camera, or lights. They have lights that are PoE power based. Imagine that, right? They're actually looking. There's also like little computers that are 100% PoE power based. You just run a PoE cable to it, little computer pulls all the power off of it. Again, as long as it's a low power device, it could be like 30, 40 watts, I think. But if you're sending 90 volts to it at 40 watts, it's only half an amp. That's not a lot of current. You could run a pretty decent little device, little screen, little computer, touch screen, whatever off of that. There's a lot that you can do with PoE. As you guys walk around campus, you probably see like the black boxes with the red letters on them. That's right now just overall tell you the time. There's supposed to be notification banners that if an emergency they need to put something up like shelter in place or whatever the case is, they could put a message up there for you. Those are all PoE power based. It's just an Ethernet cable running for them. They're capable of having an external power supply, but IT went, why? We have PoE power. We're just going to run those stuff. Right. The other good thing about PoE's smart switches is you can plug both PoE and non-PoE devices in. So you can be like, okay, let me just plug these in. And it's like, yep, oh, you need power? Okay, what power do you need? Oh, okay, yeah, I can send that to you. And then it starts sending. We're getting to that point where PoE is starting to become a very prevalent thing. It is out there for kind of like everybody to use, which is one. There also are, if you don't have a PoE powered switch or a switch that's capable of supplying PoE power, but you were like, hey, I want to put an access point in my house, they do make little devices which are PoE power injectors. All right, so again, you'd run your Ethernet in. This would just be your normal Ethernet, and then coming out this side, this would be your Ethernet plus power. And that could then go to your access point. And then up here, you'd have power coming in. All right, and that's an official PoE power injector. So again, it's following that standard. It's taking Ethernet in, it's adding the voltage and signaling and everything. It's dealing with all that conversion that needs to be done, sending it out just fine. All right, and that's how my access point at home, which kind of cracks me up because I have to have a whole router go to this PoE powers to then go to my access point. So if you're like, oh man, I really wish I could use this PoE device, but we don't have a PoE switch, you can just buy a little like cheap power injector for like 10 or 15. Probably less costly just to buy like a 10-port hub, a switch or something that has PoE on it. But if your boss is really cheap, okay, we'll just get the little one, just one device. Questions on PoE? No? All right, so we basically hit up the rest of that stuff on there. All right, network topology. All right. So what we have up on the screen here, all sorts of different network topology. Are many of these used today? Yeah, yes and no. All right. I think overall this ring, I think that makes sense why it's a ring. I don't think it's used very much. The rest of these, depending on how old the network is that you're working on, yeah, they're still going to be used. All right. Let's go ahead and start with the bus, which is this one up here on the far right. All right. So this is all equipment is connected to a main line. So we got our main line right here. All right. So all the connectors connect to that. Yep. This is not going to be fault or break tolerant. Okay, so if for some odd reason something happens right here, it's not going to be like, oh, yeah, okay, that line's broken. Let me send it a different way. There's no way. Right? It's like, oh, it basically took our one network and just divided it in two. Yay! All right. So when one device transmits information, everybody sees it, and they all go, nope, that's not for me, except for the one person who it is for, and he goes, yep, I need that. And then he takes that message in. Right? This is going to be one of the least expensive types. This is also basically how CAN bus in your car works. You have just one main trunk line that goes like zigzags all over your car, and all these different devices just hop onto that CAN bus line. And they send their data as they need it to. So it is a very simple system in the long run. It can be complex with weird oddities, but overall, not a great system. All right. Next, we have Ring, which is the one I circled. This is the precursor to Ethernet, and this uses what's called token passing. So this person would have the token, and he'd say, okay, it's my turn to transmit, and he would transmit whatever he had to transmit, or whatever. And then he'd pass the token to the next person, and that person would then do it. And then he'd pass it to the next person. After all, they got their job done, they passed it to the next one, and just keep going around the circle. It's like, oh, your turn to talk, now it's your turn, now it's your turn. It's just like moving down the line. Again, not really fault tolerant because these all transmit in a circular path. So if we break here, nothing's gonna get past that point. So if this guy is trying to send information to this guy, he hits that ends like yep. And then also this last guy can't pass the token on. So okay. So your network just like comes to a grinding halt. So not a great network again. Next we've got Star. I really makes sense. All right. So all devices connect to a central device such as a switch or hub. This is going to be the most fault tolerant of them all. Not maybe not the most, but much more fault tolerant. This one's very easy to add more devices. If you think about it, this is how most computer networks are, right? With our Ethernet. You all have an Ethernet port on your computer. You plug it into a switch. You have one cable. The next person plugs in. There's now 2 paths. Now there's 3. It just keeps building and building and building. Right? So Star is definitely a good option. So if something happens here, this person is really the only one that's really affected, and anyone trying to talk to that person. Everybody else can still talk to each other if they would need to. All right. So that's why we like that type of system better. All right. Is it still perfect? No, because again, if that guy gets cut off, that cable breaks, connector goes bad, whatever, he's still offline, and everyone trying to talk to him still can't do it. But it's very nice and convenient for it. It's like, oh, I need another Ethernet cable. Okay, run another Ethernet cable, just plug it in the switch, and you're done. Right? So a little bit of give and take going on there. Next we have Mesh, which would be down here. All right. You've all probably heard of Mesh Wi-Fi networks, right? Mesh networking. It's like, oh, you don't have internet? Get a Mesh networking today. All right. So what you can see here is every circle has direct path to every other circle. Right? Every one. So this is going to be your most fault-tolerant option. Right? It is also going to have the most cabling. Because if every device can talk to every other device directly, got a lot of cables to run. On a small network with like 3 computers, you're like, that's not bad. When you get 100 computers, you're like, damn it, I need 99 ports on every freaking device. That'll become problematic. All right. So mesh. Now, technically, you don't have to, for it to be truly everything, if it's a truly complete mesh network, every device has to be able to talk to every other device. But you could have partial meshes where it's like, okay, I've got 3 network switches. Actually, let's just go 4. All right. If we were going to do a traditional star, you'd have, everyone come back to this main device here. There, that one goes there. All right. That, would be kind of fine. This. But if we were going to go to a just like a mesh network, again, you could have your 4 devices. And for it to be mesh, one would talk to fine, be that way. I'll redraw them. All right. One would talk to 2, 2 could talk to 3, 3 could talk to 4, and then 4 could come up here and talk back to 1. So every one of these has 2 different paths. All right. So if something were to happen to this path, well, 2 could talk to 1, which could talk to 4, which could talk to 3. So there's still a redundant path there, really what it comes down. And that's the benefit of mesh, is you have a fault-tolerant system. If something happens to one link, it'd still be okay. All right. Is it a perfect system? No, because now if 2 links go down, you're still screwed. Right? So it's a little bit of a give and take. Most systems, especially like your network backbone, will be fault tolerant. It will be a mesh type system. In an ideal world. Right? Not necessarily the case. You may have a building that is so far away that the construction was so long ago that you only have one internet connection between you and it. So if that one network goes down, you're done for. All right, you either have to A, rip up the ground and put a new wire in, or B, go with a wireless direct connection. So like a point-to-point wireless system. All right. Each have their benefits and their cons. You got to pick which one is going to be your desired outcome there. So mesh is definitely a nice option there. All right. And truthfully, with a lot of devices nowadays, you have the capability to have every device be mesh. Because if you think about like your laptop, let me go with that. Like a laptop from 3 years ago. You have an Ethernet port and Wi-Fi probably built. So if you've plugged in Ethernet and are connected to Wi-Fi, you now have 2 routes to get to your computer. That is a mesh network right there. Right now, you have to have both hooked up to be truly mesh, but again, you could have 2 different options. Newer laptops, again, you might not have the Ethernet port built in. You might have to get a little fancy USB dongle or something, but you could still have that 2 root type of system. So it really just comes down to what you're trying to do. Same thing even with cell phones nowadays. Most of them have dual band capabilities. So you have 2.4 and 5 gigahertz. All right. Actually, I think we're adding 6 gigahertz to the Wi-Fi network now. So you can have a tri-mesh system with just Wi-Fi. You just have 3 different Wi-Fi links that are active at the same time. And if something happens to one frequency, interference, it relies more heavily on another one. Not the end of the world. All right. But it's really overall is a mesh network there. So kind of interesting to think about that way at least. All right, and the last one that I have up on the list is a hybrid, and a beautiful little hybrid network. As I said, most networks that you're going to be dealing with, like your traditional computer Ethernet-based network, is a hybrid, because we have a mesh for the main backbone of everything, and then a star coming off of that. All right, and then every once in a while, you could kind of argue that we actually might even have a bus network. All right, it's not a true bus. It's still kind of a ring, not a ring, a star. All right, but like up in my office, I have a phone. Actually, in my office, bad example. In my classroom in STEM 313, they said, hey, we're going to put a phone in your room for whatever purpose. But we're not going to run another Ethernet cable here. That's too expensive. On the phone, there's 2 ports. There's an incoming Ethernet and an outgoing Ethernet. So instead of going from the hub right to my computer in the classroom, I now have a phone as like a middleman there. So right here, there we go, is my phone. Ether comes in, Ethernet goes out. All it is a switch. Just okay, I've got a switch built into my phone, so that way I can have 1 port in, 1 port out, and the phone, anything that the phone isn't supposed to get, it forwards to the computer. Anything the computer sends to the phone, it sends to the internet if it's not supposed to get it. All right, it's a very simple little system. But it's just, you could argue it's kind of more bus-esque, because it's like, okay, we come into the phone, then we come out and go to the computer type of thing. They are not 2 separate networks that are being joined. It really is still just like a star, just a weird star. All right. Industrial networking. Questions for me?
You mentioned is that related to Wi-Fi?
I don't know if I don't think Wi-Fi 6 is why they're using 6 gigahertz. I think it was just a good frequency to use that is on the open frequency, so anybody can use it, I believe. I don't think there's any royalties for that one. So I think that's why they're like, hey, we need more bandwidth type of thing. And that's why they're saying, okay, we're going to add another frequency. 6 gigahertz just happens to be what they're. I don't think it's a Wi-Fi 6 gigahertz.
Wi-Fi plan. No, I know.
Mm-hmm. So, Wi-Fi 6 is just a new standard. So it's like, okay, Wi-Fi 5 was this, Wi-Fi 6 is now this, we now support this new frequency, we're supporting this more antenna, more direct connections, whatever the freaking case is. You'd have to go read the actual thing. It will be backwards compliant, so in theory, any device that's supported Wi-Fi 5, this Wi-Fi 6 device should be able to cancel. That will be fun. And again, for like the last, I got internet, so it was an old middle brother when it was like 13. You had Wi-Fi 802.11 A, B, and G. All right. B and G were, I think, like kind of cross-compatible. It was just the max frequency, but A was not. So, and that I don't know what Wi-Fi standard that was. But now we're up to like 802.11 AC or N or something like that. So for the most part, everything is now using that 2.4 gigahertz, 5 gigahertz frequency. Again, we're starting to now add 6. But until you get a Wi-Fi 6 device, like a cell phone or a laptop or something that supports Wi-Fi 6, you'll never see a difference between Wi-Fi 6 and Wi-Fi. Again, it's like, oh, yeah, we have this on this side, but this side doesn't, so I can't communicate. Kind of annoying, but that's just the way the game goes. All right, so that would be the end of industrial networking.